I have opened the provided homework MASTAN file that contains models of 3 bridges, and will now walk you through how to obtain the key results data after running the analysis. To run the analysis, we select Analysis, First Order Elastic, make sure that Planar Frame XY is selected in the bottom option menu, and then click Apply. We should receive a Success Analysis Complete message. The first item that you're asked to do in the assignment is to note and record the support conditions of each bridge. MASTAN indicates the support conditions with red arrows, as are shown here. A red arrow is drawn in the direction of each fixed or restrained degree of freedom or direction of motion. At this node, for example, we have a red arrow pointing vertically, which means that no vertical motion is allowed, and a red arrow pointing horizontally, meaning that no horizontal motion is allowed. This is a pin support. To the right of this bridge, we have a red arrow only in the vertical direction, indicating that the bridge is not allowed to move vertically, but is free to move horizontally. This is a roller condition. The first set of results you're asked to find relate to the tensile and compressive axial force and bending moments. The first thing to do is to look at a diagram of the axial force. Select, as I just did, Results, Diagrams, Axial Force. Make sure the fill box is ticked at the bottom, and then click Apply. In this diagram, red indicates compression and blue indicates tension, and the width of the colored bar indicates the magnitude of the force. By inspecting these diagrams, we can see that the maximum tensile force in the first bridge occurs in this member, E2. To find a numerical value for that force, we go to Results, Element Forces, and then select that element. At the bottom of the screen, P is the axial force, and we see that that element has a value of 41.4 kips of axial force in tension acting in it. That's the maximum tensile force in bridge number 1. In bridge number 2, the compressive forces appear to be roughly equal along the upper chord, but we can check to see whether that's true by selecting Results, Element Forces. We can now choose this element and see that the axial force is 43.83, the negative sign indicating compression. And now we can select this element, here 41.36. That means that the compressive force is a little bit larger in the element to the left, this one. That therefore is the location of the maximum compressive force. You are to find the maximum compressive and tensile forces in each of the 3 bridges. You're also asked to find maximum values of bending moment. We can find those by looking under the Results, Diagrams, Moment Z item, clicking Fill at the bottom, and choosing Apply. Here we see moment diagrams. The maximum value is indicated at the point where this shaded area of the diagram has the largest magnitude, independent of whether it's blue or red, indicating positive or negative moment. If we look at bridge number 1 at the top, it appears that the maximum moment may occur here in the middle of element 1. To find a numerical value, I'll choose Results, Element Forces, and select this element. I now need to go down to the bottom left corner of the screen and move this position slider to the middle and click Apply. After doing that, I see that the moment value is 1.475, and this slider indicates that that value is being given at the midspan of element 1. For our purposes, this is probably enough precision, and I would feel comfortable reporting that value. You need to accomplish this for the remaining bridges in the model.